Today we're going to be talking about the distance formula, and here is the formula that we're going to use. If we want to find the distance between 2 points, and let's say that point A is the point x1 comma y1, and point B is the point x2 comma y2, here is the formula that we're going to use to find the distance between A and B. The square root of, in parentheses, x2 minus x1 squared plus, in parentheses, y2 minus y1 squared. Now, what we're going to do in this case is I'm giving you 4 points, and we want to find the lengths of segments AB and BD. So first of all, let's see what this figure looks like that has all of these vertices on it. So if we graph negative 1, 1, here's our first point. B is negative 4, 3. So we're going to go to the left 4, 1, 2, 3, 4, and up 3, 1, 2, 3. So this is A, B. C is the point 3, 2. And D is the point 2, negative 1. So we have, here was point A, point B, point C, and point D. So we would like to find the distance between all of these points. And we can draw these segments in if you'd like. Kind of looks like these line up on the same line, doesn't it? So we'll see. Okay, now what we'd like to do is find the lengths of segments AB and BD. So let's start with AB. Now remember, AB had the points negative 1, 1 and negative 4, 3. So negative 1, 1 and negative 4, 3. So AB we can label as x1, y1. And negative 4, 3 would be x2, y2. And I'm going to write out the distance formula here. So this is the same formula that I had up above. So I'm going to write out x2 minus x1 squared plus y2 minus y1 squared. And let's plug our numbers in. So we're just putting in negative 1 in place of x1, negative 4 and in place of x2. So we're going to have negative 4 minus negative 1 squared plus y2 is 3 and y1 is 1. 3 minus 1. Squared. Well, remember, two negatives together make a positive, so we have negative 4 plus 1, which gives us negative 3 squared, plus 3 minus 1 is 2 squared. Let's see if this will make the plus sign properly. Negative 3 squared. Negative 3 times negative 3 is 9. 2 squared is 4. So we end up with the square root of 13. And if we use a calculator to approximate that, we get approximately 3.6. That is the length of AB. So AB ends up being, let's see if we can make this properly. AB equals 3.6. Now, let's do the length of segment BD. Now, BD uses the points -4, 3, and that's point B. Let's go back up here. D is 2, -1. So again, we're going to use the same formula. We're going to label our points x1, y1, and x2, y2. And we'll use our distance formula. Again, it really does help to write it out for each problem. It helps you to remember it. And before long, you'll have this thing memorized. So let's plug our numbers in. We're going to start with x2, which is 2, minus x1, which is -4. y2 is -1, minus y1, which is 3, and that's all squared. So let's simplify this. We have two negatives to make a positive, so we have 6 squared. And we also have -1 minus 3 is -4 squared. Well, 6 squared is 36. -4 squared is 16. So if we add 36 and 16 together, we end up with the square root of 52. If we take and use our calculators to approximate the square root of 52, we end up with approximately 7.2. So the length of segment BD is approximately 7.2. And I should have used the approximately symbols, which are these two little squiggly lines, with the other segment as well. It just means when you're taking a square root and the answer isn't exact, that this is a rounded answer. So it's approximately correct, 7.2. So that's how you use the distance formula. Don't worry if you're not quite sure at this point what to do with this. We're going to be getting an awful lot of practice in class, and I will be there to help you. So thank you very much, and we'll see you next time.